So here we're back in section 4.3, looking at primes and greatest common divisors. Continuing from our last video, we want to define what is the least common multiple of two positive integers. So let's suppose you have two positive integers, a and b. The least common multiple of those two integers, a and b, denoted the LCM of a comma b, is the smallest positive integer m that is a multiple of both a and b. So we want to get a feel for the least common multiple. Let's do an example where we find the least common multiple, the LCM of both 12 and 18. So we want to first consider different multiples of 12. And we're doing 12 times 1, 12 times 2, 24, 12 times 3. Now we're only looking at positive multiples, 36, because remember the LCM is always a positive integer, so we only want to look at positive multiples. 12 times 4, 48, 12 times 5 is 60. 12 times 6 is 72. 12 times 7 is 84. 12 times 9 is... Oh, let's do 12 times 8. I missed 12 times 8. That's better. 96. Yeah, okay, we'll just stop there. It keeps going, right? Multiples keep going. Now, when we want to look at multiples of 18, like 18 times 1 is 18, 18 times 2 is 36, 18 times 3, I believe is 54, and they keep going. I think we've already found our smallest common multiple. So where you have a common multiple of 36 right here, and that's the smallest one. We haven't found any others actually, but that's it. So it turns out to be LCM here of 12 and 18 is 36. Now, if we had some really big numbers, it would probably take all day to search for multiples. So we're going to find a more efficient path, and we're going to look at a technique for doing that. Here's an important fact. If you have a prime power factorization of A as P1 alpha 1, P2 alpha 2, so on and so forth, Pk alpha k, and for B, you also have a prime factorization of P1 beta 1, P2 beta 2, so on and so forth, Pk beta k, with the Pi's prime, and in this case, we're going to say the alpha i's and the beta i's are both greater than or equal to 0, then the LCM, the least common multiple of both A and B, you're going to write out your common primes, P1, P2, and so on and so forth, multiply together Pk, and we're going to look at the maximum of their powers. So we're going to look at the maximum of alpha 1, beta 1, and then for P2, the power is going to be the maximum of alpha 2, beta 2, and you keep that procedure going up until you get to the last prime, and your power is going to be the maximum of either alpha k or beta k. And that's it. So it should remind you of our technique for finding the GCD. In those cases, finding the GCD of A and B, we look at the minimum for the powers. Minimum of alpha 1, beta 1, minimum. So here we're doing the max for LCM. So let's do it. Let's do some exercises. Find the LCM of each pair of integers. Here I'm looking at 1, We got 3 to the 5th times 5 squared times 11. And b is going to be, let's see, 2 to the 3rd times 3 squared times 5 times 11 to the 4th power. So I have this in prime power factored form. Notice a doesn't have the prime of 2 though, so we'll write here for a, I'll write 2 to the 0 times 3 to the 5th times 5 squared times, for 11, we'll use this color, 11 to the 1. And for b, we have what? 2 to the 3rd, using colors here, times 3 squared times 5 to the 1 times, here we got times 11 to the 4th. So the LCM of a and b is going to be 2. So you're going to take the larger of the powers, so you're going to take the 3rd power. And then for the prime 3, you copy that down, you're going to take the larger power of 5. And then for the prime 5, you're going to take the larger power of the 2. And then for the prime 11, you're going to take the power of 4. So that's it. You could leave your answer that way, perfectly good, or you could multiply this all out. So I'd be perfectly happy with that as an answer, but I'm going to go ahead and multiply it out just to see what that turns out to be. Sometimes your numbers are too big to multiply in a calculator, but I think this one is handable in a calculator. I'm multiplying everything out in my calculator. I got a big number of 711,552,600. Be 711,552. No, 711,552,600. It's the LCM, so it's huge. Definitely don't want to do that the long way, listing out all the multiples. This shortcut is very nice. Let's do another. A is 2 to the 4th times 3 times 5 squared times 11 times 13 squared. And b is 2 squared times 3 to the 4th times 5 times 13. And it looks like we're missing a prime of 11 in b, so I'm going to write this as 2 squared for b, 3 to the 4th times 5 times 11 to the 0. Since there's none 11, we'll say 11 to the 0. And times 13 to the 1. Oh, and the 5 back there, I'm going to put that 5 to the 1. As for a, let me go back and write a. We got 2 to the 4th, it's green. Blue is going to be 3 to the 1. Red's going to be 5 squared. We got a turquoise color. How do you get that turquoise color? There it is, times 11 to the 1. And we got sort of an orangish color. 13 squared. So that's not 24 right there. That is 2 to the 4th at the beginning of A. I wish it would straighten up. There it goes. So the LCM, A and B, is going to involve okay, that should have been yellow, right? Yellow, 2 to the 4 should be yellow. It's going to involve a 2, and the largest power is a power of 4. It's going to involve a 3, largest power of 4. It's going to involve a 5. The largest power is a power of 2. It's going to involve an 11, if I can get 11 here to work. It's going to involve a power of 1 and 13. 13, the largest power is a power of 2. So I multiply that all out. So you could leave it like that. That'd be perfectly fine to leave it like that. But 2 to the 4th. I think my calculator can handle this times 3 to the 4th times 5 squared times 11 times 13 squared. I got on my calculator a big 60231 600. So it looks like 60,231,600. At least that's what my calculator says, and I'm not great at typing. So who knows? Maybe you want to double check that. I'm more interested in that you can get the correct prime power factorization for the LCM rather than multiply those in your calculator. All right, number 3, we have A equals 4410, so 4,410, and B equals 2,058. So these are not factored into prime power form, so we want to do some factoring first. I'm going to take 4410. Notice that's divisible by 3. When you divide 4410 divided by 3, gives you 1470. 1470 is divisible by 3. Divide that by 3, you get 490. 490 is not divisible by 3, but it's divisible by 2. Divide that by 2, and you get 245. 245 is not divisible by 2 or 3, but it's divisible by 5. I divide that by 5, I get 245 divided by 5 is 49. We know 49 is 7 times 7. Those are both primes. So A, writing that down, is going to be 2 to the 1 power, 3 to the 2nd power, times 5 to the 1 power, and then 7 to the squared. All right, so I have A done. Now we need to do B's factorization. Where am I going to do that? I'll do that. Let me do it in the upper left corner. Erasing my first factored tree, making a second. Let me get this. It's just quit writing there. No. There it goes. 2058 is factorable by 3. 2058 divided by 3 is 686. 686 is divisible by not 3, but 2. You divide that by 2, you get 343, and we know 343 is 7 times 49. 49 breaks up into 7 times 7. So we're talking about 2 to the 1 times 3 to the 1 times. So no 5s in here, so we'll say 5 to the 0. Well, then you got 3 7s. So we'll say 1, 2, 3 7s, that's 7 cubed. So if I'm finding the LCM of A and B, we're going to take the common prime of 2, and the maximum power here is just 1. And for 3, we have a prime with a maximum power of 2. And we have a prime of 5 with a maximum power of 1. And we have a prime of 7 with a maximum power of 3. I could leave my answer like that, but I'm going to go ahead and choose to multiply it out. 2 times 3 squared times 5 times 7 cubed. Looks like it's 30,870 according to my calculator. So that's calculating some LCMs. An important fact in the grand scheme of things, I'll call it a theorem. We won't use this probably, but it's important overall. If A and B are both positive integers, then there's a special relationship between the GCD of A and B and the LCM of A and B. The GCD of A and B, when you multiply it by the LCM of A and B, you get the product of A with B. Nice little result. All right, I think we'll quit this video and we'll finally go on to the last video where we actually do